Hi folks, and welcome to our last lesson that is without bonus lessons, of course, that we follow this training. And as you may remember, I mentioned somewhere at the beginning of the training we are going to take a look at Mospline a little bit more in depth, and specifically the L system built into Mospline. Now, this lesson will be split in two parts. In the first part, I'll show you how you can create jellyfish with just a few clicks, and then Mospline will slowly reveal its power to you. In second part, I'll really briefly introduce you to L system, which is really similar to programming, but that should not really scare you off, since the possibilities of L systems are endless. And you will see once we get to those L systems that they really cannot be explained in a few minutes. They well deserve a complete training volume for themselves. Since we are going to obviously work with Mospline, I better load one, and for that jellyfish I had in mind, because this is also a user request. I decided to do it because I think this setup is quite simple and works pretty well in most situations. And here under Simple tab, I'll first have to add some segments, so let's try 50. Like this, and really spread those guys completely, because that's what I need for this jellyfish. I hope that the jellyfish is correct term. Someone will correct me if I'm wrong on this one, so let's proceed. Now let me just briefly doodle that. I will hide this guy for a moment, and what I want to achieve is to have that tentacles really obeying the natural motion that you would expect to see from the jellyfish in water. So they should really go slowly up and down, and if we, for example, pull this guy, then we should expect those tentacles to go down. I really think it would be much more easier when I do this setup, and things will be clear then. Now I have to have some sort of a control for bending these guys up and down, and that is exactly what this Mospline will give me. Under this bend, I'll control the opening and closing with this, so I might as well add this to HUD, and I will right click on it, do show always, so I really don't have to dig through all these tabs to access this setting. What I would also like for this guy is to have some sort of a variation in thickness, and I can do that with step effectors. I will load one, and maybe I will reset this spline and flip it. Maybe you will be able to see this if I can pull this guy. Now let's open this in a new window, because on the end of this menu there is a show in separate window command that will give us this guy, and I can show you all that commands that are accessible via this right click. So I will flip the spline, and we'll get that difference in scaling. I'm not sure that you can really see that right now, but it will be much more vivid once we offset these guys a little bit. So if this is going to be some sort of a jellyfish, then we have to have some sort of a dynamic component to it, so it should really move naturally and wiggle or something like that. I can achieve that by loading a particle modifier into the Mospline, so I will set this to include, because I want to include some sort of effect, and this fields guy is simply a place where you can load these particle modifiers. Now, from experience, I can tell you that this turbulence, wind, and gravity work solid enough with this Mospline guy. In fact, just turbulence and wind. So I would rather use one of them. And although you would go for a wind, because it's much more natural, I will actually select turbulence, because I think it gives me better results. Of course, you are welcome to experiment. So I will load the turbulence, close this window, and unfortunately Cina 40 doesn't automatically load particle modifiers into generators that can accept them. That should be fixed by Maxon because I think it's really logical. Now let's drop that turbulence inside and you will see something happening. And if I press play now, well, the things will really not behave as expected. And first we have to change some things here and look for the scale that pretty much works for you. So I would say much lower than this. Let's go with maybe 100 here, and although it really doesn't look quite good, I will just decrease the frequency, so the amount of jitteriness in this motion. I hope the jitteriness is really real world. Let's go here with 20, and I think this would be okay for now. So let me stop this, go back. I should also increase the time, so let's go with 1000 here. I will say 1000 here, do a expand to full time because we want to see the effect without breaking the motion by pressing this little guy. So now I have a dynamic component to this, and I also have a control, so I can bend this guy down or up, so it works combined. And really, to pull this a step further, I'll play with some settings here under Object tab. Here I want to offset these splines so they get a little bit of these curvatures, and if I do that now, it will really not work as expected. But if I change this to separate segments, then if I offset, let's go even to 50%, it will work as expected. So let's press play and see what do we have and how about that. And actually I will lock this Mospline and click off so we can see that Mospline's green color, and I still have this control for opening and closing, of course. So I can really mimic that motion, that natural motion from that jellyfish, and you can see that I can still move this guy, and you can even go a step further with this. I will stop this, go back, and I will add a formula effector to this guy, and we'll just enable scale here, and you'll get a really interesting effect. So it's like some sort of deep sea jellyfish, and I can even decrease this time maybe to something like this, and the effect is really cool. So that was our jellyfish. I hope you like this setup, and now we can dig into L system in the second part of this lesson. So let's get rid of everything in the scene, and I will load a fresh Mospline, and I will set it to this turtle mode. Okay, so either turtle or L system, however you want it, and you will see some sort of a plant in the viewport which is built from spline segments, and here under object the settings stay the same. Now here under turtle, all I can say is, well, welcome to world of parametric. That means absolutely everything is set with parameters, and this can be a little bit scary at the beginning, but I'll show you a few simple examples just to get you going and to push you in the right direction, because this L system is a really vast subject and it deserves a complete volume on its own. Now let's just for a second ignore this area because it's really scary, and I will explain you this value step here. So let me just zoom in a bit so you can see that in action. And first is the growth. So it means how many segments, figuratively speaking, because I have to really use terms that may not be correct, but it will give you a good understanding of it. So here is the actual growth of these guys based on the settings here. So you can create multiple sections. So I think it will be much easier to see. So completely new generation of branches. So let me set this to default. This default angle really determines the angle of each new segment that is created. Once again, controlled by this area here, and we will get back to this area, but let me just first explain this so you can see that in action. It really changes the angle, and you can see some really wild stuff going on. Okay, so let's reset that to default. Also, now this is the default scale. For example, if I play with this, you can change the scale settings of that spline segment that consequently controls the potential scale of the sweep profile in sweep nerves. This default movement simply tells how long is the movement step. So from here to here is that value also for this guy, and let me just show you that in action. If I play with this, and it simply increases the length of the segment. Let's delete this doodle guy, and I'm pretty sure you can understand now why this is the last lesson, and I'm also sure you can understand that we cannot go in depth with this, and what kind of the power is hidden in this Mospline. So this tropism really controls the, let's say, natural tendency of the tree, figuratively speaking, to go towards the ground. So it would be some sort of gravity settings. You can see that in action. So it really hangs the tree down, again figuratively speaking, because I really want to explain this in language that you can relate to, because this Mospline in this turtle mode is really very similar to programming, and I really don't want to choke you with all that technicalities. So here is the randomness. I'm sure you understand that. The seed for that randomness, these are the multipliers. So for example, if you change this, then each next generation of segments will be scaled by that multiplier. I hope that makes sense. You can see that in the viewport. And you can uncheck this grow angle, scale, or movement. Now, let me get rid of this completely, but not by deleting this guy. I will delete this premise and these rules, because I want to explain this, and I will really give my best to explain this one. This is somewhat complicated, but just bear with me for a moment. This premise guy, it's actually a container for everything you state here as a rule. And you see, I have my help file docked, and these are the rules and commands that are available for Mospline in turtle mode, and it really looks scary. But let me just show you a few simple examples, and hopefully it will not look that scary. So here I will enter a simple rule, and the most common command in Mospline is this F, which means really move the turtle forward. So you are moving the virtual turtle, which leaves a spline trail behind, and it's far more complicated than that, but let's just leave it at that. Other simple settings are, for example, a rotation of that turtle. So let me show you the rule. I will say here that F, we can go with A. So our first rule will be A, and A has to be equal to something. So A equals F. Okay, so that is our rule. Here, once I type in that rule and refresh, you will see something happening here. Now, I basically instructed this spline now to move forward, because A means, or equals, move forward, and it will move according to this value. So if I set this to maybe a larger value, it will move by the value set here. Okay, so I can reset that to default. This angle guy won't do anything now, simply because I didn't instruct my turtle to turn somewhere. Okay, so if you take a look here under commands, you have a few rotation options. So I will use maybe this first one, which means it will rotate the turtle clockwise. Okay, so let's try that. So I will put that plus sign in front of this F. So let's see what happens. And you can click here in this context ignore, which I will explain, to refresh the system. So watch what happens. This guy now has turned by exactly this value, and you can control that with this guy here. Let me undo that. So basically what we are now saying is that our A equals move this guy forward, so draw a line which is this long and rotate it clockwise by this amount. I really hope you are still following. So all that movement and rotation is contained in a single rule. What if I create another rule? Let's say B equals, and let's choose another rotation option. So let's take a look here. It's really impossible, especially for beginners, to work without this command list. So let's use maybe this arrow up sign and see what will happen if I type arrow up, and once again I will move forward. Well, nothing will happen. The reason for it is because all the necessary movement here and creation is executed through this premise. So I have to tell it here that I want to use that B. So let's type B and click here to refresh the system and see what happens. So now this guy rotated in another direction. So you can see clearly that is the case. I think that things are beginning to make sense now a little bit around this L system. Now, what if I want to really create quite a few of these segments and turns for this guy? So maybe I will add here plus F, some move forward and rotate once again. So let's see what happens, and that's really cool. And all this is contained in our rule A. So let's maybe try once again plus F. So we are steadily moving this guy, and we can go even a step further, and this can work. This can be applied, but what if you want to close this and form a circle? Well, it's much better idea to create a loop. Okay, so I will delete all these rules, and here I will say F equals, so using the letter F, and that F will also serve as a premise, and it will serve as a move forward command. So if I type here F and F here, let's see what happens, and it draws this guy. If I now type here plus F, let's see what happens, and it creates a circle, and the reason for it is there is a looping through this command. So F equals move forward plus move forward, and then this F equals move forward, and so on and so forth. So you now have a little bit of an insight how these parametric splines are created. So they are pretty much the same, but on a far more complex level than you can imagine, but the principles used are the same. So I hope you will appreciate them now a little bit more. Now there is one thing that I want to change here, and I want to change the use color. So I will set some color for this turtle spline, and I will here under object display just the line. I can lock this guy, and we will now have a nice blue circle that we made parametrically here with our turtle spline. Of course, now this default angle will really control the radius of this guy, and this movement will control pretty much the size. So I think that things will have more sense now. Let's create another simple object with help of these rules and premise. And before that, let me just briefly explain this context ignore. Well, basically here you can type some sort of a rule that will tell anything that is inside these rules to be overridden. So maybe you would say that if some segment is larger than some value, then that will be ignored. And I really hope I didn't complicate this too much. So basically it's a way of creating an ignore a rule for something inside here. So let's delete all these guys and we will create a new Mospline. So let's say that we want to create a simple object with a simple rule. Well, let's go with letter A, and you can use any convention or style or letter that really suits your need, but the idea, the concept is really the same. And here, which is really close to programming, you will have to find your own style, your own concepts and ideas that work best for you. So here I will enter letter A because I want to use that A as a placeholder for everything I put here under this A equals rule. Now let's put F as a move forward, and if I want to create a new branch, a new segment, I have to put that under these signs that are called brackets. So open bracket and enter the up arrow sign that will instruct this segment to rotate, and then I will put once again letter A because I want to create a loop, and I will close the bracket. So let's see what do we have now. We have some sort of a curvature, but beware, you can use these values here. So if I set this to 90, watch what happens. So 90, I will create a rectangle. So there is a lot of power in this. And for example, if I enter here plus, that means I want to rotate something again, because this plus guy, if you take a look here, also means rotate the turtle clockwise around the vertical axis. So these are the rotation guys, and if you're looking for specific rotation, you really don't have to understand initially, but really try it out and see what works for you. So now I'll actually instruct this whole setup to rotate, but I will copy completely this segment and I will paste it, and watch the result. It will once again create the loop and it will close the surface, figuratively speaking. So if I click off, you will see the result. Now you can have fun with this guy, of course, with this start and end settings, and maybe it is much more appropriate in this separate segments. So you can really draw things out, and this L system is absolutely mind-blowingly fantastic. Now, one thing that I should mention here is a result string to console. So it will print all the rules and all the execution functions to console. So here is our actual rule printed. So this is what this A equals gave us within our premise. Okay, so I hope that makes sense. Let's clear out this once again and let me show you another simple example. Now let's say that we want some sort of a simplified plan. So I will create a simple rule for that. So first let's call our rule maybe X, because it really sounds cool. So X equals what? First, if I want this guy to go upwards, so if I maybe just press F here, and in our premise type X, I will just get this guy pointing in this direction. If I want it to point upwards, I have to instruct it. So type that up arrow sign, and now my guy will point upward, and this angle defines how it will point upward. I hope you are following this. Now I will just click off somewhere here so we can see that blue line, because this is locked and we can freely work on it. So if I want to create a new branch, if you remember, I have to create a bracket, and here I can enter another command. So let's rotate and move forward and close the bracket. Let's see what that gives us if I click anywhere other than this rules box, and this is what we have. This is really cool. We got a new segment here which is controlled by this value. So if you play with these values, they will change things. This is a really important concept to understand. So let's maybe add another rule. So we will open brackets, so new segments, and let's maybe use a different rotation. So I think this is called \sign, and let's once again move forward and close the bracket. Let's see the result, and we have a completely new branch going upwards. So let's try adding one more bracket. We will type the end sign. I hope that is called end sign, and also type F for moving forward and closing the bracket. Let's see what we have now. So you see, I'm really branching out these guys. I can also maybe, just for the sake of the tutorial, add one more bracket, minus sign, and also move forward and close the bracket. So each of these brackets contain a new segment. So let's see how that works, and that is the branching. This is really simple branching. Now we can change the values here. So for example, I can tune this down just a little bit. So let's say, let's go with 45, and I can now create a new rule. Let's say A, which will equal move forward this complete setup. So move forward X. Okay, so if I now enter here A, watch what happens. It will create a completely new branch of the branch. So this is a beginning of, let's say, a really simple plant, and this Mospline is especially suitable for creating plant-like structures. So if I reset this to default, now hopefully this default premise and rules won't be that scary. I should just mention that this T stands for tropism, so it's really adding tropism to branches, and I think with this we will conclude our tutorial, and just want to take the opportunity to thank you for this purchase. And as you may know, the bonus lessons will follow after this, and also there will be a topic on c4dcafe.com, and yours truly became an administrator on that very popular C4D forum. There will be a topic about this training where you can suggest bonus lessons, where you can simply leave your impressions and tell what you want to see in future trainings. That is really important and helps me collect information on one single place. So voice your opinions on that topic. I believe it is also worth mentioning that now I'm part of the Maxon beta team, so that will help me create even better training content, and I will be able to provide training content regarding new features much faster. So once again, thank you for the purchase and watching, and I really hope you enjoyed this MoGraph volume. Huge amount of work went to it, and I'll let you be the judges of how it came out. That's it. See you in the next volume, project training, or bonus lesson.